The microstructure determines the mechanical properties of the produced part. In order to simulate these mechanical properties, we apply the finite element method. Using the microstructure obtained from the cellular automaton simulation, we extract a small part that we have identified as representative for the whole microstructure. This extracted part is also called the representative volume element, and it might look like this. Mechanical material properties describe the behavior of the part under various loading conditions. To compute these properties, we use crystal plasticity models to calculate the resulting stress as we deform the representative volume element. From this simulation, we can extract mechanical properties such as Young's modulus and the yield stress, as well as direction-dependent behavior and the evolution of the microstructure.